Welcome to Linkerd Day at KubeCon Europe, and our talk on scaling progressive delivery at EarnIn. Hi everyone, I'm Joe Brinkman. I'm a senior manager on the platform team at EarnIn.
I'm Kush Trivedi, platform engineer at EarnIn, working with Joe on delivering better platforms. So before we get started, by the raise of the hands, can we know how many of us here are using progressive deployment techniques like Canary or Blue in production? Cool. And how many of us here are looking to adopt progressive delivery for their organization in production? Interesting. Maybe I take this as a fear of progressive delivery or lack of the tools of who are not using progressive delivery right now. So by the end of this talk, we expect that you will be able to gain some insights on how you can adopt progressive delivery, scale them, and make your engineers know that it's a frictionless process and it's betterment for all.
So today we'd like to walk you through our journey to progressive delivery, including challenges we had with legacy tools, our migration to Argo CD, the use of Linkerd and Gateway API for rollouts, some of the tools we built to help developers, some lessons we learned along the way, and a brief demo at the end. First of all, what is EarnIn? It's a financial technology company founded in 2013 to promote financial wellness by offering earned wage access. For those of you not familiar, earned wage access is a service that allows employees to access a portion of their already earned wages before payday. We have 4 million customers, handle around 4 billion API requests per month. We have over 700 microservices and about 1,000 deployments per day. We started moving to Kubernetes in around 2020 and actually used Linkerd v1 a long time ago, and migrated to Spinnaker in 2022. Spinnaker was our first foray into continuous deployment. It gave us a lot of standard features that you look for in a continuous deployment tool. However, over the course of a few years, we started facing some challenges with Spinnaker. What challenges do we face? Well, Spinnaker doesn't support Kubernetes native deployments or the GitOps model. It was difficult to maintain, wasn't highly available, and we often just had to restart it to resolve outages. It also had limited Datadog integration, which made it challenging to monitor deployments. We also lacked the standard deployment model since each application had its own dingy file and its own custom pipeline for deployments. The automated canary analysis feature was also frustrating to use. I think we had less than 10% of applications actually using canaries. So we migrated everything to Argo CD last year. So we migrated to Argo because we wanted to have a single source of truth for pipelines using a GitOps model and avoid all these bespoke configurations that we had. We've been able to reduce the complexity of our pipelines and simplify the workflows used by developers. We've also added extensive automated testing for these pipelines to ensure that when we add new features, we're not going to break everything. And all this sounds awesome, but we still had a problem. Actually, yeah, go to the next slide. Just to give you a brief overview of these pipelines, this is our standard pipeline that we have now with Argo, deploying to dev, stage, and production environments. You can see we've got a post-deployment testing step after dev with auto rollbacks, which was requested by our QA team. We've got manual judgment steps before stage and production, which allows developers the chance to look at the results before moving forward, and a few other steps that send notifications or evaluate scorecards in our internal developer portal. We still had a problem with this. What was missing? Well, even though we migrated to Argo, we still had failing deployments. Why? We had an external metrics operator, but no Datadog integration during rollouts, which meant that we could deploy broken code. And if an application had to be rolled back, it was often difficult and frustrating for developers. What we needed was a fully automated progressive delivery solution, and that's where Linkerd comes into play.
Thanks, Joe. So before diving into what was the complete architecture of progressive delivery solution at EarnIn, let's take a look at what were the components which helped us to even get to that solution. The core to that component was Linkerd. EarnIn in its service mesh journey had already migrated to Linkerd in early 2024. We have done a KubeCon talk at India on how this migration journey looked like. If anyone is looking towards that, I would encourage them to watch that talk. To give a small overview, Linkerd is the lightweight and one of the fastest mesh right now. As you just saw in the opening remarks, with Linkerd v2, we migrated to Rust proxy. We have built-in observability for whatever services which have injected with the Linkerd sidecar. And Linkerd also support granular traffic control via Gamma initiator. We'll learn more about what Gamma means here. Before Gamma, Linkerd used to use SMI to do the traffic splitting and traffic controlling. Linkerd has strong community support and straightforward integration with a lot of CNCF toolings, including but not limited to Argo CD, Flux CD, and more. Now with Linkerd, you do get traffic insights and granular traffic monitoring. To enable traffic splitting and more granular control over your traffic, you need to use Gateway API in conjunction with Linkerd. What Gateway API means? Gateway API is a project which was started by Kubernetes community to standardize L4 and L7 load balancing capabilities for ingress and load balancer objects. With Gamma initiative coming in, Gamma over here means Gateway API for mesh management and administration. Gateway API's capability were increased, not just from north-south traffic, but also to east-west traffic for service mesh administration and management. Linkerd is fully compatible or fully compliant with Gateway API CRDs. And what does this mean is, with a single set of CRDs, you could actually orchestrate your north-south traffic as well as your east-west traffic. With Linkerd and Gateway API already here, we had traffic splitting, we have traffic controlling. What we were missing was an intelligent layer, which would come in the picture, tell Linkerd and Gateway API at what time, how much traffic should redirect it to stable service, how much should go to canary service, when do you want to move ahead, and when do you want to roll back to your stable service. That's where Argo Rollouts came into the scenario. Argo Rollouts, by definition, is a Kubernetes controller which helps you orchestrate and enable progressive deliveries using strategies like Canary and Blue-Green. In simpler terms, what Argo Rollouts does to Gateway API and Linkerd is telling them redirect X% of traffic to stable service, Y to the canary service, and with automated matrix evaluation through the matrix provider, it can also make intelligent decision that should we go to the next step or should we just roll back to the previous step. With Argo Rollouts, Linkerd and Gateway API all involved together, they enable you to have safer, granular, and better production environment and deployments. Now let's take a look into how the complete architecture of our progressive delivery tooling look like. So over here, you can actually see, let's say we started a deployment of service any ABC. For the first step, we are redirecting 20% of the traffic to canary replica set, and 80% is going to the stable replica set. Rollout controller is the one which is controlling that how much traffic percentage should go to canary and how much percent should go to stable. We have Gateway API and Linkerd working behind the reams to make sure that all the abstraction is working properly. One of the key things to note over here is the external URL for other clients for this service is remaining same. So let's say you have a service A. All the clients will call it service A.service.cluster.local instead of having two different URLs. And internally, Gateway API and Linkerd will have two backend references for your parent service, which will make sure that the traffic splitting is happening properly. Rollout controller also have a CRD called analysis template, which makes you or which lets you control or make automated decision on the matrices. We at EarnIn use Datadog as our auxiliary provider, but it has integration with New Relic, Kubernetes jobs, and a lot more matrix provider, where you can decide when do you want to move ahead in your rollout stage, or if the matrix are not looking good, you have the ability to roll back to the stable replica set. Now with this architecture, let's take a look at how the implementation and the rollout look like at EarnIn. The first key thing in implementing the canary deployments at EarnIn was making sure that we are able to come up with a common, abstracted, and a granular configuration. The configuration with our Helm values should be granular enough for the platform team to maintain it in the long term, as well as they should be descriptive enough for developers to be able to understand what are the configuration available to me. On the right-hand side in the image, you can actually see we abstracted away a lot of things where we provided developers with the capability to use n number of matrices and queries with specific query intervals and error thresholds whenever they want to roll it back. We also let them use custom steps. So let's say if a developer do not want to go with 20, 40, 60, 80, they can give whatever steps they want to have in their rollout. The next step was to add support of Gateway API CRDs in our Helm chart, which are specifically HTTP route and gRPC route. With our services still using service profiles, what we wanted to make sure was that whatever changes which we are introducing in our Helm chart are always backward compatible. So the next thing which we wanted to do was all the services which are going to use rollouts should get gateway API CRDs, and all the services which do not have rollouts enabled should get service profiles. And as of Linkerd 2.16, it's mentioned that all the service profiles are fully compatible and can be replaced with gateway API. On top of these things, there was again one major challenge on our journey to adopt Canary, which was to make sure that we have zero downtime migration going from deployment to rollout CRD. What does this mean here is, so if any one of you are using Argo Rollouts, you need to use a custom CRD called Rollouts, and you need to give away deployments. So to have zero downtime migration, we had a 3-step process of going from deployments to rollouts. First one was we referenced our existing deployments from the rollouts. Instead of creating complete custom YAML, we were able to get all the features which we had already added in our deployment YAML directly from our rollout. As in the below image, you can actually see we are referencing our deployment object from the rollout CRD. Second thing which we did was releasing 2 patch versions of our Helm chart. First patch versions enabled the developers to have rollouts and deployments running parallelly. On the basis of what scale down we have given over here, once the rollout is scaled up completely, the deployment will be scaled down to 0. As soon as that happens, you need to bump up to the next patch version, which will deprecate the deployment from your Helm chart. So there would be no hallucination by Argo Rollout Controller, and there would be only one CRD, which would be spinning up pods for you. All of these sounds, I know, are pretty complicated for a company which has more than 700 microservices with 250 engineers. So the next thing which we wanted to do was making sure that all of these changes, all of these complexities are abstracted away from the developers, where they don't need to bother about patching up the Helm versions, bumping up the Helm version, configuring all of these stuff, and rather, everything should be seamless for them. That's where the need to create an abstraction or empowering our developers with self-service tooling came in to the picture. So we needed to create abstraction for developers because developers would not be interested in knowing how Linkerd and Argo rollouts work, but what they would want is give me a simple configuration UI where I can define what all Canary parameters I have, what steps I want, how the thresholds look like, and everything. As well as we wanted to empower teams to use Canary without having a friction from the platform team, and everything should work seamless for them. So the first stage in this process was to enable Argo Rollouts UI plugin in the Argo CD app page, where if you see on the right-hand side, you can actually visualize the complete rollout process through the Argo CD application itself. So whenever your deployment gets started, you will be able to see at what step the rollout is progressing at, what's the traffic percentage, as well as how does the automatic Canary evaluation is happening. The next step in this journey was to create a plugin or create an abstraction in our internal developer platform. So we at EarnIn are heavy users of internal developer platform. We obviously believe that each and every developer should be empowered to self-service his infrastructure. So what we did over here was we created a custom plugin where developers would be able to configure what Canary, do they want Canary or not? Do they want analysis templates or not? So they can actually enable, disable, and configure each and every parameter of Canary which we have specified in the Helm chart. There were a few of the validations which were majorly driven by the UI itself on what all configuration they can put in. After they trigger the deployment, we have an asynchronous Argo workflow which gets triggered in the backend, making sure that all the changes are properly being rolled out to a central GitOps repository. The Argo CD application is working fine, and all the traffic rerouting is happening. Once that is done, we send a call back to our internal developer platform where we would have your Canary changes were applied successfully, they failed, or if they were in progress. With this, there is minimal interference as well as minimal friction from the platform team, and developers were easily able to use Canary and modify all the parameters. Let's take a look into a very brief demo on how does this actually look in the complete Argo CD, HTTP routes, and all the CRDs, and how Linkerd and everything play together. So just before starting the talk, and we were having a mess up of this demo conversation, we had started a rollout of a sample service, which is in our sandbox environment. Hopefully, there should be something to look at there. Perfect. So we have a demo service, which is being hosted from a sandbox environment for us. Over here, as you can see, the health status is suspended, which means the rollout is still progressing. Now let's take a look at how the UI plugin for the rollout look like. So if you see over here, right now, our service is at the pause 20 minutes, and 20% of the traffic is being redirected to the Canary replica set. As you can see over here, we have got two services created. One is the regular service, and one is the service with Canary. As you can see the name over here. Now, all the magic internally happens in this HTTP route, where we have referenced parent ref as the service name, and then we have got two backend refs, which are going one to the Canary, second to the stable service. And then Argo Rollouts is the one controlling what all steps are going to happen, and at what point, how much percentage of traffic should get redirected to which service. So if you look over here, here are the steps which are being specified for that. And at the last but not the least, the metric provider integration which we are talking about. So we have got analysis template over here. Over there, you can see, as of now, we have integrated with latency rate metric and the error rate metric. So if the latency increases by 10 seconds, we are going to roll it back. Or if the error rate increases by 10% of the service, we are again going to roll it back. And you can see we had around 3 failures just to make sure the demo is correct, which is why you can see there are multiple replica set, but still the deployment is happening from the older replica set. Because there were 3 failed deployments, due to which analysis template had to roll the service back. And yeah, that's all in a nutshell on how the implementation, how the ease, and how the self-service of implementing and improving progressive delivery at EarnIn look like. We would appreciate any questions and any feedback which you would have on this talk. And sorry for the miss, which we had to create earlier because of the tech. That's it. Thank you.
Looks like we have 5 minutes for any questions or comments that anyone has.
Can you switch? Oh, yeah, sorry. Hi. Do you plan similar things for more infrastructure services as, I think, databases or which are not using Gateway API generally? As the next step, not only web applications.
Got it. So as of now, we are not doing anything for our infrastructure services on the database layer. What we have seen, or how the history at EarnIn looks like for now, is we have been shipping changes which have not been tested properly, or which have been tested in production, or there have been some external client changes which are impacting that service. So as of now, the major focus of this was to make sure the code which we are shipping, the error rate and the latencies for the code which we are shipping is stable and better in production. So hopefully, once we have got at least 90% of Canary adoption at our place, these will be the things which we'll be looking into. Okay, then I think that was our time, folks. Thank you.
Thank you.